to Aaron the Teacher YouTube channel, where physics is made easy and so enjoyable. I ask you of just one thing: subscribe, like, and share. And where necessary, leave a comment in the comment section to know where you've been watching from. Let's get into our learning for today. Once again, may God bless you and give you understanding. In Jesus' name, Shalom. Amen. Okay, we are now having our sample scenario we are going to use to come up with the laboratory report for the practical. And this one is looking at a concave mirror. I'm going to be reading through as you try to follow along with me and we go together. In one of the schools during project work, the senior foreigners opted to make a reflecting telescope. All the other materials were available except the concave mirror of focal length 20 centimeters. One of the learners bought a concave mirror, but there was no label on it. Thus, you are provided with one concave mirror from the laboratory with similar properties like the one the learner bought. Sensitize the senior for learners whether to use it or not. Now, we are having the scenario at hand, and it's going to guide us onto our practical. As we all know the flow and all the stages we go through to write practical, where it has got the aim, the hypothesis, the materials, the setup, as we shall flow together. Let's go together and we see how the aim is. Now, in my video or in this particular practical, I've used this aim. It is saying an experiment to determine the focal length of a concave mirror provided so as to determine if it can be used by the learners to make a reflecting telescope. And the hypothesis, the focal length of the mirror is between 18 to 22 if it is to be used by the learners to make the reflecting telescope. Now, take note of the range that I've set. In the scenario there, we are given a single value of 20 centimeters, but then I come up with a range in which this 20 is going to fall, so that I cater for whatever value I will be getting. It may not necessarily be 20, but at least it should be within a particular range, and according to this is the range I have. I don't know which range you've set as for you, but if there is a different range you have got as you, just leave a comment in the comment section and we shall revisit it in that particular way and we learn together. And then we are having the variables under independent. There is object distance. This time I've used a u, another person will use a b, or another person will use m. They all mean the same provided you execute the data coherently. Dependent variable, we are having image distance v. Controlled, we are having the light intensity. In the materials, there is light, mirror, there is mirror, there is a mirror holder, there is white screen, emitter roll, and then a light source. And then we shall move on to another thing, that is the experimental setup. As you cut it, the experimental setup has got the distance of the object, which is u, then the distance of the image, which is v, and my white screen is between the light source and the concave mirror. So it should be in place to draw a very neat and a very well labeled diagram in order to communicate very well what you are doing. And then we move on to the steps. The steps I'm having: step A, the apparatus arranged as shown above. Then a distance u between the object, which is the light from the bulb, and the mirror was measured, beginning with a distance of 90 centimeters. Procedure C, the screen was moved towards and away from the mirror until a sharp image of the light was formed on it. Procedure D, the distance V from the mirror to the screen was measured and recorded. And then procedure E, procedures B to D were repeated for more values of U equals to 80, 70, 60, 50, and 70 and 40. And then procedure F, we are having the results were tabulated in a suitable table, including values of U times V, that is the product, and values of U plus V, that is the sum. Now my sum, I've put it in brackets to show that it is moving together. If you leave it open, it will show that it is only one value which is moving, particularly maybe someone may assume it is a U or it is a V, but when you combine it with a bracket, it shows that the value was moving together and it was obtained as a single value. Then we shall move on to the procedure G. A graph of UV against U plus V was plotted and its log S was determined. And lastly, the procedure H, the focal length of the mirror was determined from F equals to S. We are having F equals to S because I've plotted the graph of U, V against U plus V. But another person will plot U plus V against U times V. And the expression F equals to S will change to give us F equals to 1 over S. How does it come to be like that? It is practical work. I suggest you leave a comment in the comment section for us to have a visitation about that section, but it is more practical. We may not stay on it in this video. So the next stage, which will be now the carrying out of the experiment, and I invite you to follow along with me as you do it together. Comment in the comment section how your apparatus were and which challenges did you find in connecting or setting up the apparatus, and we shall have a review about that. But I welcome you so much. Please don't forget to like, share, and subscribe, and leave comments in the comment section for engagement between me and you, to see where you've been watching from and what you've been learning. Let's go on. Okay, this is how the setup is going to be. I'm having the source of light, I'm having the screen, and then there is the mirror mounted on the mirror holder, as you can look at. And there we go. So we are going to be varying. We are going to be varying the distance between the mirror and the screen. And at the start, we are going to begin with a distance of 90. We go to a distance of 80, up to a distance of 40. So how am I going to vary it? You can look through, and so I'm going to measure the distance between this up to the other side to be 90. So I come at this point and I place my mirror at this point. Then I also make sure that this point is also at 0, so that the distance is 90. Then I come and move my meter rule. I come and move my screen, which is here. I move it until I see a sharp image being focused on the screen. And if I'm to zoom my sharp image, this is where it is. I'm having it here, if I may. My sharp image is here. It has been formed, and therefore we'll measure now the distance between the mirror and the screen. And that distance I can just get 90 minus distance between here. So my distance, it is at the screen is at 68.2, meaning I'm going to get 90 minus 68.2 to get the distance between this region from here to there, and that is the U. If you put it into the computer, you get 90 minus 68.2, you end up getting 21. So I record it 21.8. I now vary the distance between I again vary the distance between the mirror, now this time at 80, and at 80 it will be at this point here, and I again bring my screen, I move it again until the sharp image is focused, and if I may bring the camera near my sharp image, there it is here, as you see this one here. I again measure the distance between the two, and that distance I just get, this time it is 80 minus the distance which was at this point, it is at 57.8. We are measuring coming from this side up to this side, so I'm using this upper scale. This one here is one that I'm using because I'm DC up to the other side. So it is minus 50. You said we are getting 57.8. So 80 minus 57.8 giving me 22.2. Again, go back. I first remove my screen. Again, I vary the distance again up to this time up to 30. Up to 30. Make sure this line is coinciding at that point. This line here should be coinciding at 30. And the same, even this other side should be at 0. Meaning the distance there is at 70. I bring again my screen, I vary, or I move it, and there it is. My image has been formed at that point. It is here. What do I do? Again, measure the distance between the screen and the mirror. The distance, it is very easy. I just get, this time it is 17 minus. At this point you're having it at 64. So we are having at 46.5. So it will be 70 minus 46.5, giving us 23. So at 70 we are having 23.5. Okay. I'm running with more. Again, move this distance up to 40, like this, up to 40. Again, move the screen until when the sharp image is formed, and my sharp image is at that point. It is at that point. What do I do? Again, get. This time it was at 60 minus. It is at 36 exactly. You see it? 36. So it is at 36. So 60 minus 36, giving us 24.0. Okay. I move now to 50. The distance between the mirror and the source of light is at 50. What do I do? I again move the screen to and fro. I again move the screen up to. This time it is at 23.2. We see it? 23.2. I get 50 minus 23.2. I'll be getting 26.8. And then I'm remaining with the last one, which will be at 40. At 40, the distance between the mirror and the source of light. Then I move my screen once again, and if my sharp image is being formed at that point, this is it. Yeah, that is it. Then I again measure the distance. I just get 40 minus, this time it is at up to, I will subtract minus 11.4 here, 11.4, where the screen is here, 11.4, 11.4, giving us 28.6. And that will be the end of the practical. Now we are remaining with just presentation of data and the graph work, and then we conclude. So let's move on. So we are now going to first get the columns UV and U plus V. UV, I'm having in brackets centimeters squared because I'm multiplying U, which is in centimeters, and then V, which is also in centimeters, so the units will be squared. Then U plus V, I'm putting it in brackets because it is a formula, since it is giving U plus V, so it becomes to be a formula. That's why I'm putting it in brackets. And likewise, the units are also in brackets, they're in centimeters. So I was going to first get the columns for each of them, but let's come to UV. UV, we are multiplying 90 times 21.8, and for us to determine how many like significant figures or decimal points that we are going to follow in this column, we are going to first get the highest product between the two of them. I will go on and test. I test 90. I test 90.90 times 21.8. It is giving us some 1962. Then also test for the last one, which is 40 times 28.6, giving us 1144. Automatically tells us that all which is between these two values, it is just going decreasing. Therefore, we are going to use the highest product, which is 1962, to establish the number of decimal places for the rest of the products. And as we can look, it is having 0 decimal place, meaning the rest of the products or the values in that column is going to take 0 decimal points. So this one is 0 decimal points. So we shall come on this, and it will be 1962. We multiply 80 times 22.2 to get 17 or 1776. Get 70 times 23.5 to give us that. Then 60 times 24 to give us 60 times 24 to give us 1440. And then I come to 50 times 26 to give 1340. And then last with 40, which we already got here, 1144. That is the column for U times V. Then U plus V, I'm just adding 90 plus 21.8 to give. Now likewise to this one, we are going to consider the number of decimal places. When you look through, all of them are having to 1 decimal place, meaning our answers are going to be to 1 decimal place. So I take 0.8, and then 80 plus 22.2 to give us 100. 22.2, 70 plus 23.5 to give 90.5. This plus that to give 84.0. This plus that to give 76.8, and then lastly 40 plus 28.6 to give us 68.6. And that's how our table is looking like. And then what next is now for us to plot the graph, where I'm going to plot a graph of u v against u plus x. Of course, I first demarcate my graph. I put lines on it. First demarcate it from down here. This line I draw from down up. Likewise to this one. Please make sure that your line is touching at the end of the graph. Likewise to this point. Don't draw it hanging in space. Then afterwards you come and include the arrows to show that it will still continue. And my title will be up here too, and the title will be a graph of uv against u plus v. I'm maintaining my brackets because it is a formula. So, and once again I re-echo, don't bring units in the title. The title does not need units. Don't include them there. Just write the symbols you've used in the practical and you move. The units will come when naming the axes. For instance, here we say uv into brackets centimeters squared. And likewise down here it will be u plus v to brackets centimeters full stop. And now there we are. We come now to first get our scale. Our scale, I'm having this against that. So you say 19, 62 minus 1144, giving us 818. Then I divide by 10 big squares. 818 divided by 10 to give us 81. But when you check in this scale is in the multiples of a particular scale. Let's first obtain it from here. I'm having 1, 2, 2.5 and then 5. So multiples I have 10, 20 and then 50, which are going to use from there. Then there's 100, there's 200 and then 500. When you check after me getting 19, let me say vertical scale. Now all this is your side work. Please don't include it on part of the practical. You may include it, then afterwards you cross it to show that it was side work. Vertical scale, I get highest value minus lowest value, divide by 10, giving us 1962 minus 114 divided by 10. We've gotten 81.8, and then we come and see 81.8. Where does it lie? It is lying between 50 and 100. Now, which scale would you choose of the two? Would you choose 50 or would you choose 100? Of course, we are going to take the highest, which is this. I repeat, 81.8 is lying between 50 and 100. So you're going to choose the highest scale, which is 100. And then I come and select my beginning point. My beginning point or starting value on on the vertical. We said it will be the same as getting the lowest value minus the scale, which you are going to say 1144 minus 100, giving us 1044. So that is our starting value that you are going to begin with. And we've said our scale we are going to use, you can approximate this to 100. So I'm going to begin from 144 and then I name. I come down here, meaning I'm going to begin 1044. I add on plus 100, it will be 1144. I add on plus 100 to give us, let me demarcate this. Please, we use two big squares, 2 centimeters to these ones here, not one. Take note of that, please. When we demarcate this up to here, we are using two boxes to represent our scale. So 104 plus 100, I'll get, of course, 1244. Plus 100, I get 1344. Plus 100, I get 1444. Plus 100, I get 1544. I get 1644. I get 1744. 1844. 1944. And then we are going to get 2044. And then lastly we can swap that, since our highest value is already within the scale. It is between this and that, so you can stop at 2144 as our value. We also come and do the same for the horizontal scale. Horizontal scale, we shall say it will be equals to, we get highest minus lowest value divided by, this time we are going to divide by 8. On the vertical we divide by 10, on the horizontal we divide by 8. Okay. And then from there, we now come and say our highest in this column, it is 111.8. So it will be 111.8 minus 68.6. I press 100.8 minus 68.6. You're getting 40. So you're getting 43.2. When I divide by 8, my answer giving us 5.4. I come back and check 5.4. Where is it lying? I see it is lying between 5 and 10. It is lying between 5 and 10, meaning I'm going to take the 10 as my scale. Therefore, my scale will be equals to 10. Then also I choose the starting point for the horizontal scale, for the horizontal axis also. This was for the vertical, this is for the horizontal. Starting value will be equals to lowest minus the scale, which is equals to, my lowest value is 68.6 minus my scale, which I'm going to use 10, giving us 58.6. Therefore I'm going to come and say, let me first demarcate this and up to there. So I will begin at 58.6. When I add on plus 10, it will give me 68.6. When I add on, plus that, I will get I'm going to get 78. But instead of us maintaining this 0.6, we can choose to first remove it to to look somehow smart, let's use just 58, 68, and then we shall use 70. We shall use 88. Here we shall use 98, and then we add on plus 10 to give us 108. We add on plus 10 to give us 100, and then see 100. So you're having 98 plus 10 to give us 108 plus 10 to give us 118, then plus 10 to give us 100. This will be 28 plus 10 to give us 138, and that's the scale we are going to be using. So I'm done with demarcating my graph, and what I'm remaining with is just to plot the values. The values we shall again go through how to plot the point. I say how to plot the point. We get the point to be plotted minus the starting value, and divide by what one small square represents. One small square represents. All this is your side work, please, and it is so helping to you. So I encourage you to always be doing it, because as you see, it's really helping us. So I can choose to first put all these values into what we call small squares, and I just be counting small squares. How? I come on the vertical. First of all, on the vertical, when you come back to our scale, it is 100, meaning one small square will represent 10 if I divide through by 10. So let me say one small square equals to, if 10 small squares are equal to 100, one small square will be equivalent to 10 divided by 100 divided by 10, giving us 10. This is what you're going to be using. Then likewise, on the horizontal, if 10 small squares represent we took 10, how about one small square? Then one small square will be equivalent to 10 divided by 10, giving us 1. That means when it comes to the vertical, I'm going to give just an illustration. Say for instance, I want to plot 1962. 1962. I'm going to get that point minus my starting value, which was 1044. So 1044. Then divide by what one small square represents on the vertical. It is representing 10. It is representing 10. So I divide by 10. And when I press in the calculator, 62 minus 044, giving us 918. Then divide by 10. I'm going to count. Now this one is giving 91.8. I will approximate to 92 small squares altogether. So I'm just going to generate a small table for only squares, and I will say, if I will say on the y-axis, and then on the x-axis. On the y-axis, the first one I'm having 92. Let me generate them at once. The next one I'm going to have 776, and a starting value which is 10,044, and it is giving us, then divide by 10. So I'm going to take 73. It is giving us 73.2, but since 2 is less than 5, we are going to round off to 73 small squares. Therefore I'm going to plot 73. And come again, 1645 minus 0.044 divided by 10. This one is given 60 of them, 60 small squares. And do the same until the last. Divide by 10. Now this one is giving us 39.6, but you're going to round off because 6 is more than 5. You're going to round off to 40 small squares. Okay, 1340 minus 0 divided by 10. Likewise, this one is giving us 29.6. We're going to round off to 30 small squares. And then the last one, 1144 minus 1044. Then divide by 10. Exactly, you're getting 10. So you're going to plot 10 small squares. I do the same for the x-axis. All this is your side work. Please don't mix it up with your actual work. But as you see, it is so much important. You need it. Okay. Then we have on the vertical. I'm just going to sample once again one value. Say for instance, we want to plot 111.8. I'm going to come 111.8 minus my starting value. We took it to be 58. Then divide by the scale. Our scale, we said one small square represents 1. Therefore, if I'm to write it here, if I'm to write it on the x-axis, say for instance I'm plotting 11.8 minus our starting value, which we took to be 58, divided by 1. We are getting 53.8, and we shall approximate to 54 since 8 is more than 5. So that's what I'm going to plot 54 small squares. After getting that, I think we can now just flow to getting these ones. Also 102.2 minus 58 divided by 1, it is giving us 44.2. So I will plot 44 small squares. I also come 93.5 minus 58, giving us that. Then divide by 1 is giving us 35.5. Now 35.5, this is a 5, meaning we are going to take it as it is. We shall estimate a half of a box, and that's where the point is going to be, because 5 is the exact one. We have got 84 minus 58 divided by 1, we are getting 26 small squares. Then second last, 76.8 minus 58, giving us 18.8. Of course, we round off to 19 small squares, so there will be 19. And then the last one, 68.6 minus 58, giving us 10.6, which we are going to round off to give 11 small squares. Now here I've simplified my work so much. I've simplified my work so much. Meaning I'm just going to come and count these small squares. They are the ones I'm going to plot. And I begin x, then y. So let me begin with the x. In the x, the first one I'm having 54. I come and count. I begin counting from the start here. I count 54 small squares. Of course, from here to here there are 10. From here to here there are 20. So 20, 30, 40, 50. Then I add on plus 4 up to this point. And I move upwards. Upwards I'm counting 92. I also come and count from the start. So 92, it will be from here to here 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 92, which is at this point. Good. Which is at 30 at this point here. Let me repeat. 10, 20, 30, 40, 50, 60, 70, 80, and then 90. I trace this line. I trace it up to, you said up to 50. I trace it up to, from here up to this, and it will be at this point. It will be at this point, and it's where I'm going to plot. That is one point. Then I come again. I'm on 44 against 73. So I count 44 small squares from the start. From here to here, 10, 20, 30, 40. Then again 44. I count 44 from here. That is at 44. Then on the vertical, I'm counting 73. I again begin 10, 20, 30, 40, 50, 60, 70. And I add on 73. You realize it is going to be at this point. At this point here. I circle it. We use a dot with a circle surrounding it. Then we come now to 35.5. 35, you're going to count 35 small squares from the start. Of course, 10, 20, 30, and 35. Then the 50. This 5, we shall estimate it to be in between that small square there. It is between the 50th and the 60th line. So we shall take it to be in between those two. And then I'm going to trace that against the 60. So I count 10, 20, 30, 40, 10, 20, 30, 40, 50, 60, and it will be at this point. I've estimated halfway of that box, and it is this point here. We go to 26 against 40. I first count 26 from on the horizontal, 10, 20, and then 26 is here. I trace it upwards, and then likewise 10, 20, 30, 40, and it will be here at this point. That point. So far so good. We are remaining with 2 more, and the second last, we are having 19. I count from here to here, there are 10. I just add on up to 19, which is here. So 19 is at that point, and 19 is against 30. I count 10, 20, 30, up to that point. And then the last one, which we are counting 10 small squares. So we are counting 11 against 10. So 11 on the horizontal, they are here, against 10 on the vertical. And then if I trace it, it is giving at this point. It's giving at that point, and there is my graph. I don't know how yours is, but if you are lost or you need some help, just leave a comment in the comment section, and we shall move through together. But I'm so happy that you are following. Please don't forget to like, subscribe, and share the video. Our next stage is now for us to draw the line of best fit. We are having 6 values. There's 1, 2, 3, 4, 5, and we are going to draw these values, the line of best fit, to divide these points equally. If I place it, I place on this line, I place on this, I place on this, I place on this, you realize it is going to pass through 1, 2, and 3, and then it is going to touch this one, then it is going to leave out this one and this one, and we shall take that to be a line because it has divided the graph fairly. It has left 1 and 2, one this side, one the other side, but this one is touching, which is good. So I don't know how yours is looking like, but if it is coming out, just comment. That's fine. If it is not coming, still comment, and we shall have a way forward. Then likewise, I come to draw the triangle. Triangle, we say that we look for a point where this line is cutting through. And for instance, if I check through my first point, it is this point here. I draw this line to come downwards, up to down, to meet the horizontal axis. And likewise, I think I mean the horizontal axis. Likewise, I also look for a point on the horizontal where the line is also cutting, and I realize it is cutting here. I also draw this same line. This line is going to be the tape. Now take note your point should always be within the triangle. All of your points, choose a point outside this last point and choose a point outside this first point, such that all your points are within the triangle. Then I draw to represent that it was a right angle triangle, and also come this side. I just complete it from here in a dotted line up to their point. Likewise, down here I also dot it. etc. So I'm just remaining with getting these coordinates or these values here. So now to get these coordinates, of course, we shall take this to be x2 and y2, then x1, y1. And how are we going to get them? We come and read this value on the horizontal axis and read this value on the vertical axis to give us y2. This one will give x2, and then this one will give y2. So I just locate along my axis. For instance, here, my value before this point is 108, meaning I'm going to say 108 plus, into brackets, how many small squares are after that value. If I count, these are 5, then plus 2, giving us 7. Then times what one small square represents on that axis. We said one small square represents 1 on the horizontal, meaning I'm going to multiply times 1, giving us 108 plus, into brackets, 7 times 1, which is 7. So 108 plus 7, it is giving us 115. And that is the value which I'm going to put here as my x1. Then I go to y2 also. It is going to be at this point. And y2, I'm also going to come and set the value which is before this point is 1944. Then I say plus, into brackets, how many small squares are there? There are 8 of them. And times what one small square represents. We say on the vertical, one small square represents 10. So it will be times 10, giving us 1944 plus, into brackets, 8 times 10. And the answer we are getting 2024. And that will be the value at this point, 2024. That is done. We come still to this point, and to this point we are also going to get the value before this point is 58. So I'm going to get 58 plus, into brackets, how many small squares are there? There are 7 of them, times 1, giving us 58 plus 7, 58 plus 7 giving us 65, and still the same thing on the vertical. The first value before it is 1044, then plus into brackets up to that value. How many small squares are there? Mine is giving 5 of them, and then 5 times what one small square represents, which is 10. We shall end up getting plus into brackets 5 times 10 giving us 1094. So those are the values we are going to use here. I'm going to use 65 again as 1094. So what you are left with is to calculate the slope and come up with the conclusion. Of course, we shall not forget the errors and the mitigations we took in the practical. Let's move on to that. We are getting our slope S equals to change in UV divided by change in brackets U plus V. For physics, we shall denote the change as that small triangle you are seeing there. We may not necessarily write the whole word as in change in UV divided by change in U plus V. But if you write still, there is no penalty, but it is more of time consuming. I just follow along. My slope is equivalent to 2024 minus 1094, then divided by 115 minus 65. I'm getting upward or in the numerator as 930, then divided by 50. At the end of the day, I'm getting my S equals to 18.6 centimeters. And since we related S to F by this expression, F equals to S, therefore it automatically means that my F is also equals to 18.6 centimeters. And that's how our slope is. So then we move on to the sources of errors and precautions, and then the conclusion, and we shall call it the end of the practical. Under errors or sources of errors and their precautions, the first one, you're having parallax error, and its precaution are saying align the eye directly with the scale. Yeah, let the eye be at a perpendicular angle with the scale. Source of errors 2, inaccurate object or image distance placement. And the precaution we have is measure and double check the distances accurately before reading or recording them down. Another one is the difficulty in identifying the sharpest image. Yeah, it can arise an error because it is not all that easy to focus that sharp image, but still the precaution would be slowly adjust the screen position to find the sharpest focus of the image. And our last, but not the least, source of error is the incorrect reference point on the mirror. And then the precaution we have is measure from the mirror's pole. Those are the sources of errors we managed to get. They are not the only ones. As you see, there is an ETC, meaning they are still more beyond this. Okay, we are moving on now next to our conclusion, which are saying that since the focal length F equals to 18.6 centimeter is within the range of 18 centimeter to 22 centimeter, then the hypothesis is true, and so the lens can be used by the learners to make a reflecting telescope. Yeah, always remember to join the value you've got to the hypothesis and prove whether the hypothesis is true or not. And after proving whether it's true or not, you go and give an advice based on the scenario, and for which in this case our advice is the learners can now use the learners can now use the lens to make a reflecting telescope. Yeah, thank you very much for learning. May God bless you. Leave a comment where you've understood, leave a comment where you are confused, and we shall have a review about that point. May God bless you. Shalom.